All right, so we've been reviewing how to find limits at a point in time, at a particular x coordinate. So if that's an x coordinate of 1 right here, this is an x coordinate of 1 right there, then the limit from the left of this is what? The limit from the left is 1. Comes up right there. Okay? The limit as x approaches 1 from the right is 2. The limit as x approaches 1 from both sides is does not exist. Okay. Left side, right side come together. Okay? So that's graphically. If you type in your calculator and did your traces, left and right, you would see the left side was 1, the right side was 2. You can see it that way as well. Okay? Algebraically, x minus 2, x plus 2, x minus 2, plug your 2 in, that's going to be a limit of 4. Right? You okay with that? You agree with that?
What's the log?
That should be a limit. Sorry. I typed the wrong thing. Sorry. So that's what we've been doing. Limit at a point in time. Everybody clear before I move on? Today we're going to look at limits at infinity. So not this, not the vertical infinity, not this one you've been talking about, right? Not that infinity. Okay? That's the answer of infinity, right? The question I'm asking is what's the limit as x goes to infinity? That's what we're asking today. Does that make sense, the difference? Instead of x equal to a point, instead of x equal to 2, what's the limit at x equal to infinity at the ends? What's the graph do at the ends? The left end or the right end?
What's the highest y value?
So what's the y values approaching? Okay, what are the y values coming to as x goes to infinity? So today we're going to look at limits as x goes to infinity, and we're also going to review logarithms and exponents. You learned these pre-cal rules last year in middle school. If the exponent is on top is bigger than the exponent on the bottom, what's the horizontal asymptote? What is it? Say it louder.
None.
None, thank you. Does not exist. That same question could be asked this way. What is the limit as x approaches infinity of 4x cubed over 3x squared? That's asking exactly the same question. So instead of finding the horizontal asymptote, which is what it is, the question is what's the limit as x goes to infinity, as x goes to the ends? It does exist. It is. Oh, it just doesn't exist. You're right. Does not exist because that one is bigger than that one. That makes sense to you? It's the same pre-cal rule. This is the calculus behind the pre-cal rule you learned. I'm showing you why the pre-cal rule is there. It's because of this limiting equation right here. If that number is bigger than this one, watch what happens if I plug infinity in. Remember the first step of solving any limits, you do what? You plug the value in. So if I plug infinity in here and here, that is 4 times infinity cubed over 3 times infinity squared. Which is bigger, infinity cubed or infinity squared?
It's infinity.
It doesn't matter, it's bigger. I'll prove it to you. How many integers are there on the number line?
Infinity.
Infinity, thank you. How many even integers are on the number line?
Half of infinity.
Half of infinity, which is still infinite, but it's half as big.
Isn't that the
It is, but there are orders of magnitude. Think about it. She's exactly right. There are exactly half as many even integers as there are total integers.
But it goes on forever.
They're both infinite, but one is twice as big.
Sure.
You need to get that idea in your head, okay?
I get what you're saying. It's just weird.
It is weird, okay? Which is bigger?
The one on top.
Infinity or infinity squared?
Infinity squared.
Infinity squared is an order of magnitude bigger. Exactly right. So in this case, infinity cubed over infinity squared will reduce down to the same algebral rules apply, right? X cubed over x squared is really x on top, yes? This applies the same way. Infinity cubed over infinity squared is really infinity on top. Well, a limit can never be infinity, right? A two-sided limit can't be infinity, so we say it does not exist. Does not exist. Are you okay with that? Get your head around that. So infinity does have orders of magnitude. Some things are bigger than other infinities. I'm sorry, it's just the way it works. All right, this pre-cal rule right here. If they're the same, then our horizontal asymptote is the ratio of those guys, right? Here's why. The limit as x approaches infinity of 4x cubed over 3x cubed is really 4 infinity cubed over 3 infinity cubed. Anything divided by itself is 1. And you could have done that math right here and been done with it. I'm showing you the infinities because the same algebra you've been doing for years works with infinities. Okay? They're just a concept. They divide out the same way. All right? So here, if the number on bottom, if the exponent on bottom is bigger, we say the horizontal asymptote is 0. The question I'm asking is, what is the limit as x approaches infinity of 4x squared over 3x cubed? Well, that's 4 infinity squared over 3 infinity cubed. Which one's bigger? The one on the bottom, right? If I divide those out, just like if I divide these out, I'm left with x on the bottom, right? Here I'm left with infinity on the bottom. You okay with that? Infinity on the bottom. Which means that I'm dividing by a massive number. Anything divided by infinity goes to 0. The limit as you divide by infinity goes to 0, which is where that comes from.
Oh, because it's
You're dividing by a huge number,
by
right?
a huge number, it gets smaller.
It gets smaller and smaller and smaller and smaller and smaller. Should have given you all these notes. Shoot. So you have to be right.
So technically, it's like 0.00000.
0, 0, 0, 0, 0, 0, 0, 0, 0, hit
1.
to infinity with a 1 on the end of it. Yes,
Yeah.
exactly right. You're getting progressively smaller and smaller and smaller.
Since it's infinity, it's always getting smaller.
So we just round that to 0.
You round that to 0. That is the limit. You're not really rounding it. That is the
Oh,
limit. That is
yeah,
the
true.
number you're approaching. If you keep going forever, you're getting closer and closer to 0. Those are both yours. You have 2 copies of everything. I make way too many copies. I make way too many copies. Sorry I didn't get those notes beforehand. Next time I start talking, ask me if I have notes for it. All right, so they're okay with the limits at infinity.
Yes.
All it is we're talking about is these 3 pre-cal rules. It is the math, it is the calculus behind those 3 pre-cal rules. All right, the next topic is, that we're calling today, is a log and exponent review. So we'll refresh your memories on these basic rules for logs and exponents. Did you do any of that, Alex? Okay, good deal. All right. So your basic rules for log and exponents is if you're multiplying, you can rewrite that as an addition problem, or vice versa. If you are dividing, you can rewrite that as a subtraction problem, or vice versa. And if you have an exponent on top, you can bring that down as a coefficient in front, or vice versa. Okay? These are important when you go to simplify exponential and logarithmic rules. So for example, down here, I want to simplify this one right here. I have e to the ln of x plus ln of y. You cannot simplify that yet because you have 2 ln's on top. you have to reduce that down to 1 ln. Well, a plus sign is the same thing as a multiplication problem. So we rewrite that as ln of x times y. Well, once you get that pattern right there, e to the ln, or, you know, a base to the same numbers, like 2 squared, 3 cubed, okay? Whenever you get the same thing on top and bottom right, you can cancel those out. That's the whole point of simplifying, is we can cancel those out, leaving with x and y. X times y. Same thing right here. This is a logarithm example, but works the same way. Log base 4 of 4 is the same thing as e of ln n, or 2 squared, or whatever. Once you have the same base and the same value, you can cancel those out, and you're left with y plus 3 right there. And on your graphs right here, just to refresh your memory, exponential graphs, unless they've been shifted, always go through 0, 1. Exponentials always go through 0, 1. Logarithms always go through 1, 0, unless they've been shifted up or down, left and right. Okay, so let's look at a couple problems before I get you guys started here.
Let's do it.
Okay, so as I'm looking at this, we're evaluating the limit as x goes to infinity. I'm using what rules?
So pre-cal
The pre-cal rules.
are the same.
They're the same right here and here. So all I care about is the coefficients right there. Phi divided by -2 is -5/2. If I look at 223, what's happening there?
Way bigger on the bottom.
Way bigger on the bottom. That's infinity to the 5th power.
So it's
To divide by infinity takes you to
0.
0. That's really 3 divided by infinity, so that is 0.
Wait, 215 isn't this positive 2?
5 divided by -2. Right, you look at the x's, what you care about.
So you don't care about the -1?
The negative where?
Like the -3 divided by 3. Is
So
negative.
those are constants, completely irrelevant when you're talking about infinity. Okay, so you're going to ignore those. If you looked at the problem this way, it might make more sense to you. 5 infinity minus 3 divided by, I'm going to rewrite it this way, -2 infinity plus 3. So if you compare infinities right here, does that 3 make any difference? Doesn't make a bit of difference, right? If we're talking about an infinitely big number, the 3 is irrelevant. So we're going to ignore those. They don't make any difference to us. All you care about is the largest exponent variable. Everything else is irrelevant. It's going to go away as you get to infinitely big numbers.
So there is a horizontal one.
So this one was a horizontal of -5/2. This was a horizontal of 0. So this one, let's look at this one right here. What's happening here?
They're the same. Ooh, we're approaching 5, so just plug in 5.
Plug in 5. This is not approaching
Oh,
infinity.
okay.
This is not the pre-cal rules. This is the limit as x goes to 5. This is what you did all last week. See the difference, okay? These are the limit as we go to infinity. These are the pre-cal rules. These are a point in space. This is factoring, this is conjugating, whatever you do, okay? You see the difference? Everybody good? Okay. All right. And then just on, what problems are we doing here? I'm not sure what problem we're doing here. If if we were to take it, for instance, and look at, try to find a good one here for you. This one right here. If we were trying to simplify that, I have a base of 2 right here. What do I need over here? Base of 2, right? How can I turn 1/2 into a base of 2? It's 2 negative 1. That's exactly right. So now I have the same base on both sides. So I can say log base 2 of both sides, cancel those out, and I have 3x minus 1 equals to negative 1. I can just solve that.
Tell me what you did to the 1/2 real quick again.
So what power of 2 would give me 1/2 power? Would give me, I'm sorry, what power of 2 would give me 1/2? 2 to the 1 is 2. 2 to the 0 is 1. 2 to the negative 1, 1/2. 2 to the negative 2, 1/4. 2 to the negative 3, 1/8. Okay? That make sense?
Yeah.
All right, so let's get started. I've selected pieces out of each one of them. Let's see if I have those here somewhere. There you go. You can see what the problems are right there.